Welcome back to the AI-900 practice series on Skills on Cloud. If you landed here without watching part 1, go back and start there because machine learning fundamentals build on the AI workload concepts we covered. In this video, 10 questions, all focused on machine learning fundamentals on Azure. We are covering supervised, unsupervised, and reinforcement learning, AutoML, model evaluation, and deep learning. And question 10 will require you to actually calculate precision and recall under pressure, which is exactly what the real exam demands. Let's go. If you are new here, Skills on Cloud is your home for IT certification exam prep and interview prep. Subscribe and hit the notification bell so you get every part of this series the moment it drops. Now, let's get into the questions. A quick orientation before we start. The machine learning on Azure domain carries 20 to 25% of the AI-900 exam. That means it is the single largest domain on the paper. Today's 10 questions map directly to what Microsoft tests in this domain. You will see questions about the 3 core types of machine learning, how Azure AutoML works, how to evaluate model performance using metrics like precision, recall, and accuracy, and the difference between overfitting and underfitting. If you nail these 10, you are in great shape for the real exam. Let's go. Question 1. Question 1 of 10. A data scientist groups customers into segments based on purchasing behavior without using any predefined labels. What type of machine learning is being used? Option A, supervised learning. Option B, reinforcement learning. Option C, unsupervised learning. Option D, semi-supervised learning. Take a moment to think. The correct answer is C, unsupervised learning. In unsupervised learning, the training data has no labels. The algorithm identifies patterns and structures in the data on its own. Customer segmentation by behavior without predefined categories is a classic clustering task, which is a form of unsupervised learning. Supervised learning requires labeled data. Reinforcement learning trains agents using rewards and penalties. Semi-supervised uses a mix of labeled and unlabeled examples. Key memory trigger, no labels plus finding groups equals unsupervised learning. Question 2 of 10. A game-playing artificial intelligence agent learns to maximize its score by taking actions in an environment and receiving positive or negative feedback for each action. What type of machine learning is this? Option A, supervised learning. Option B, unsupervised learning. Option C, deep learning. Option D, reinforcement learning. Think carefully. The correct answer is D, reinforcement learning. Reinforcement learning involves an agent that interacts with an environment. The agent takes actions and receives rewards for good outcomes and penalties for poor ones. Over time, it learns a policy that maximizes cumulative reward. Game-playing artificial intelligence agents are the most well-known example of reinforcement learning. Supervised learning requires labeled examples, not environmental feedback. Unsupervised learning finds patterns in data. Deep learning is a neural network architecture that can underpin reinforcement learning, but is not the type itself. Key trigger: agent plus environment plus reward equals reinforcement learning. Question 3 of 10. A business analyst with no coding experience needs to train a machine learning model to predict customer churn. Which Azure machine learning capability allows them to do this with minimal manual intervention? Option A, Azure Machine Learning Pipelines. Option B, Azure Machine Learning Compute Clusters. Option C, Automated Machine Learning, also known as AutoML. Option D, the Azure Machine Learning Designer. Think about what each option does. The correct answer is C, Automated Machine Learning, also known as AutoML. AutoML automates the process of selecting algorithms, tuning hyperparameters, and evaluating models. A non-technical user can specify the target column and the type of task, and AutoML will trial multiple approaches and recommend the best model. Azure Machine Learning Pipelines orchestrate multi-step workflows and require code. Compute clusters provide infrastructure. The Designer is a drag-and-drop tool that still requires the user to build the pipeline manually. Key trigger: automatic algorithm selection and tuning equals AutoML. Question 4 of 10. During a machine learning project, A data scientist sets aside a portion of data that is never used during training or model selection. This data is only used once at the very end to evaluate the final model. What is this dataset called? Option A, training data. Option B, validation data. Option C, test data. Option D, feature data. Take your time. The correct answer is C, test data. The test dataset is held out completely and used only for the final evaluation of the deployed model. Training data is used to teach the model. Validation data is used during model development to tune hyperparameters and compare model versions without contaminating the test set. Feature data is not a standard dataset split term. Key memory hook. Training teaches, validation tunes, test evaluates once at the end. Question 5 of 10. A machine learning model achieves 98% accuracy on its training data, but only 52% accuracy on new unseen data. What problem does this describe? Option A, underfitting. Option B, data leakage. Option C, overfitting. Option D, class imbalance. Think carefully about the pattern you see in those numbers. The correct answer is C, overfitting. Overfitting occurs when a model learns the training data too well, including its noise and outliers, and fails to generalize to new data. The massive gap between training accuracy and test accuracy is the classic signal of overfitting. Underfitting is the opposite, where the model performs poorly on both training and test data. Data leakage is when information from outside the training set contaminates model training. Class imbalance refers to unequal distribution of target labels. Key trigger: high training accuracy plus low test accuracy equals overfitting. Halfway through. How many do you have so far? Drop your score out of 5 in the comments right now. 0 out of 5 to 5 out of 5. I want to see every score. It keeps you accountable, and it tells me which topics the community finds hardest. Now buckle up for the second half, including that calculation-based question at the end. Question 6 of 10. Before training a model, a data scientist converts raw date fields into separate columns for day of week, month, and whether the date is a public holiday. What machine learning process does this describe? Option A, normalization. Option B, feature engineering. Option C, model evaluation. Option D, hyperparameter tuning. Take a moment. The correct answer is B, feature engineering. Feature engineering is the process of using domain knowledge to create, transform, or extract new input variables, called features, from raw data to improve model performance. Turning a date into day of week or public holiday indicator is a textbook example. Normalization scales numerical values to a common range. Model evaluation measures performance after training. Hyperparameter tuning adjusts model settings before or during training. Key trigger: creating new input columns from raw data equals feature engineering. Question 7 of 10. A hospital uses a machine learning model to detect a rare disease. The model flags every single patient as having the disease to ensure no case is missed. Which metric best reveals that this strategy is flawed? Option A, accuracy. Option B, precision. Option C, recall. Option D, R-squared. Think about what each metric measures. The correct answer is B, precision. Precision measures what proportion of the model's positive predictions were actually correct. If the model labels everyone as positive, precision will be very low because most of those predictions are false positives. Accuracy would actually appear high if the disease is rare, because correctly predicting the many negative cases inflates the score. Recall measures how many actual positives were caught, which would be 100% in this case, making it look perfect. R-squared is used for regression, not classification. Key trigger: if accuracy looks good but the model is useless, check precision. Question 8 of 10. A machine learning team needs a centralized place in Azure to manage experiments, store datasets, track model versions, and deploy models as endpoints. What Azure resource provides all of this? Option A, Azure Databricks Workspace. Option B, Azure Machine Learning Workspace. Option C, Azure Data Factory. Option D, Azure Synapse Analytics. Consider each option. The correct answer is B, Azure Machine Learning Workspace. The Azure Machine Learning Workspace is the top-level resource that brings together all components needed for the machine learning lifecycle, including experiments, datasets, models, compute, and deployment endpoints. Azure Databricks is a separate analytics platform focused on data engineering and Spark workloads. Azure Data Factory is a data integration and pipeline orchestration service. Azure Synapse Analytics combines data, warehousing, and big data analytics, but is not a machine learning lifecycle management tool. Key hook: one home for all machine learning assets equals the Azure Machine Learning Workspace. Question 9 of 10. A data scientist builds a model using multiple layers of interconnected nodes that progressively learn abstract representations of input data, such as images. What type of model is this? Option A: a decision tree. Option B: a linear regression model. Option C: a deep learning neural network. Option D: a k-means clustering model. Think about the structure being described. The correct answer is C: a deep learning neural network. Deep learning uses artificial neural networks with many hidden layers. Each layer learns increasingly abstract features from the input. For example, early layers in an image model detect edges, middle layers detect shapes, and later layers detect objects. Decision trees split data based on feature thresholds. Linear regression models a straight-line relationship between inputs and output. K-means is an unsupervised clustering algorithm. Key trigger: multiple hidden layers learning abstract features equals deep learning. Question 10 of 10, and as promised, this is the trickiest question in the set, so read it very carefully. A binary classification model produces the following results. It correctly identifies 100 positive cases. It correctly identifies 800 negative cases. It incorrectly labels 50 negative cases as positive. It incorrectly labels 20 positive cases as negative. Which of the following statements is correct? Option A: the model's accuracy is 90% and its precision is 66.7%. Option B: the model's accuracy is 94.3% and its recall is 83.3%. Option C: the model's recall is 83.3% and its precision is 66.7%. Option D: the model's precision is 83.3% and its accuracy is 94.3%. Now, before you answer, here is the trap. Many candidates confuse precision and recall or make arithmetic errors under pressure. Let's work through it. Total cases: 100 plus 800 plus 50 plus 20 equals 970. Correct predictions: 100 plus 800 equals 900. Accuracy: 900 divided by 970 equals approximately 92.8%. Precision: true positives divided by true positives plus false positives, which is 100 divided by 100 plus 50, equals 100 divided by 150, which is 66.7%. Recall: true positives divided by true positives plus false negatives, which is 100 divided by 100 plus 20, equals 100 divided by 120, which is 83.3%. So the correct answer is C. Recall is 83.3% and precision is 66.7%. Options A and D both misstate the accuracy figure. Option B swaps the precision and recall values. The trick is that accuracy sounds like the most important metric, but it was the distractor here. Always calculate each metric from its definition. So, what was your final score? 10 out of 10 on that last calculation question is seriously impressive. Most people make at least one arithmetic slip under pressure. Post your score out of 10 in the comments below. Now here is what is coming in part 3. We are moving into computer vision on Azure. That means Azure Computer Vision Service, Custom Vision, the face service, and how to choose between them in scenario-based questions. Computer vision questions can look deceptively simple until you hit a scenario with 4 similar-sounding services. Part 3 will give you the decision framework you need, so you never mix them up on exam day. Subscribe now. The 10-second countdown is on your screen. I will see you in part 3.